Okay, there are some properties of coherent state. So the first thing is, the first property is the mean number of photons in coherent state alpha is given by. So this is the average, the mean number of photon or the average number of photon in coherent state, which is equal to n and alpha, and so this is the average number of photon. Now we know about the n, the number operator, which is equal to a dagger a. Then putting the value of n here, so we have a dagger a, and if we apply uh, a with alpha, then we can get alpha. And if we apply a dagger with alpha, then we can get alpha star. So this is the same thing, alpha star alpha, and we have the coherent strand, and this is equal to 1. So this is equal to 1. And we have alpha mod square. So this is, we can get from the mean number of photon, which is equal to alpha mod square. Now, if we consider the alpha, the coherent state, which has the expression that we already know about this alpha, which is equal to minus alpha mod square divided by 2 summation n is equal to 0 alpha n pictorial n. If we consider this type of coherent state, then the reverse, the bra must be equal to this. And using the same relation n alpha and alpha, putting the value of alpha, so we have the value of alpha as this one, and n a dagger a, and alpha the ket, which is equal to this, putting here, and then we can get e to power minus alpha mod square. This is alpha mod square, and summation n is equal to 0 alpha star alpha e power n divided by n pictorial, and we have this. And first we apply n a with n, and then a dagger with n, then we can get n. So you can try this by yourself. This is very easy, because first if you apply this, so we can get a dagger, and this is equal to n minus 1. So this state becomes n minus 1, and then you can apply n under root a dagger with n minus 1. So if we apply this n minus 1, so you have n under root, and if you apply this, so we can get n minus 1 plus 1, and this n minus 1 plus 1. So this can be cancelled out, and you have n and n, which is equal to 1, and this n under root, and we have this n under root. So n under root square, you have only n. So this is very easy, it's no problem. Now, if this relation, if you have this kind of relation, x d divided by dx, summation x is equal to 0, x to the power n divided by n pictorial, then this must be equal to this. And in our case, we have x is equal to alpha mod square. Then you have x d divided by dx e to the power x, which is equal to summation x to the power n pictorial and n. In our case, x is equal to alpha mod square. So here we can apply this relation here using this kind of relation. If we have this, you can get this. So using this relation on this part of the equation, then we can get alpha mod square, because you have x and d divided by dx e to the power x. Instead of x, we have alpha mod square. So alpha mod square and partial divided partial mod square e to the power this. And if we differentiate, we can get alpha mod square, and this alpha mod square and this can be cancelled out, and still you have n the mod square. So it means that if we simply take alpha you can get alpha mod square. If we properly use the coherent state, then still you have the average number of photons which is equal to alpha mod square.